All right, so I'm going to make a video going over the 16 questions for the worksheet that I gave you in the last class. I'm going to try and go through this video as quickly as I can, as you guys have already been given this worksheet. You had the answer key to the worksheet as well, and now you have this to help you. So in the first question, you're asked to rewrite this in index form. So that means we need to rewrite it as a number raised to a fractional power. All right, so we're going to rewrite this as some number raised to a power. And remember, our radicand, the whole number on the inside of our radical, or whatever we're taking the root of, is our base of our index form. So that means this is going to be 12. And now we need to raise it to a power. So remember, I told you in words that this is power over index. And if you recall, the index is what root we're taking. So that means we're taking the ninth root. That means our denominator is going to be our index. So that means our index is 9. And then the power is if we're raising either the radical or the number to a power at all. So since it's being raised to the 7th power, that is our power 7. So then if we are rewriting this in index form, it is 12 to the 7/9 power. Right? Because this tells us what we're raising the 12 to, 7. And then this tells us what index we're taking, what root we're taking, 9. All right, for this one, we're going in reverse. We're given it in index form, and now we need to rewrite it in radical form. So once I know I'm rewriting it in radical form, I know right away I can draw the radical symbol, right? Because I know if I'm rewriting it in radical form, I have to have this. And remember, our base, whatever we are raising our power to, is what we're going to be writing inside of our radical. All right, but before we get started with any of this, let me just erase this real quick. Before we get started with anything, the first thing that I should identify is this is a negative number. So when I'm rewriting this, I always want to get rid of my negatives. So I know this is going to become 1 over 16 to the 8/9 power. All right, just like we learned in our last chapter, we can flip things just like we did before. When we first learn these rules, we don't just forget them and they don't exist anymore. We can continue to use them. All right, so now I'm going to start off by writing 1 over, and I'm going to write my radical symbol on the bottom. All right, whatever our base is what our radicand is. So it's what we're writing on the inside of our radical. And remember, it is power over index, power over index. So that means this 8 represents what we're raising the 16 to. So I can write this here. I can write it on the outside, or I can put in parentheses. And then the index is what root we are taking. So this index is what root we are taking, and that's what we write here, right? Because that tells us what our index is, what root we are taking. Just remember, though, if you were to write this really big as 1 over 9 to the 16/8 power, this is going to be marked incorrect because this is telling me we're multiplying it by 9 when we write it that big. All right, so remember, this is not how you want to write it. Make sure you're writing it nice and small like I did here. All right, let's move on to the next questions. All right, so the directions for 13 through 16 all say the same thing, and we'll just say simplify completely. All right, so remember, when we're trying to simplify our radicals, what we're trying to see is, are there any perfect squares embedded in this number that I can go ahead and pull out? Well, when we look at this first question, number 3, it says the square root of 16. Well, you should all know what the square root of 16 is. Right, the square root of 16 is equal to 4. So there's really no work that we do for this. You could try and separate this by 4 times 4, but there's no point to. Look at the number first. And some of you guys seem to not, when you're given a number, you seem to try to break it down every time because that's what we did to solve some of the questions. Rather than looking and saying, do I actually know what this square root is? And since we know what the square root of 16 is, we can just go ahead and take it. It is 4. All right, then the next problem, number 4, is another really easy one. It says the square root of 100. All right, so now, remember, you will have to create this list over here on the right-hand side, and also you're going to be going up to, I believe it was number 16. Same thing that you guys were given before class one day. And you look and see, square root of 100. If you're not sure what it is, then go ahead and start looking at all of these squares. Because remember, the numbers on the right-hand side are x squared, so it means if we can see this number, we can take the square root of it. So here's 100. Well, I can take the square root of 100. The square root of 100 is equal to 10. So rather than breaking anything down, I just know the square root of 100 is 10. All right, the first 2 were really easy. They were just perfect squares. Now we're going to start moving on to numbers that aren't perfect squares that we can go ahead and have to start simplifying. All right, now for this one, we have -5 times the square root of 72. So remember, when we're simplifying our radicals, we're looking to see, are there any perfect squares that are embedded in this number that are being multiplied that we can pull out? Well, if we go through this list, we know that 4 divides evenly into 72. We know that 9 divides evenly into 72. And we know that 36 does. So remember, when you know that multiple numbers do, you always take the largest one. Because then if you don't, then that means you're going to have to simplify a couple other times, which isn't bad. It just means it might take you a little bit more work. All right, so here I'm going to rewrite this as -5 times, well, the perfect square that goes into 72 is 36. So it'll be 36 times, now what, 36 times what gives me 72? And that is 2. All right, now I'm going to go ahead and separate these so this way I can focus on them individually so I know which ones I'm taking out and which ones I'm leaving in. All right, now the square root of 36 is 6. And remember, here we are multiplying these two, so I still need to multiply them here. I can't take the square root of 2, so it just drops. Well, -5 times 6 is -30, so it is -30 times the square root of 2. All right, there's nothing else that we can do for this number, and that is the furthest that it can be simplified. All right, now I am going to erase this really quick, and I'm going to show you guys what happens if you didn't pick the largest number. Maybe you picked the smallest one. So maybe you're like, oh, I know 9 goes into this because 9 goes into it 8 times. So if you rewrite this as 9 times 8, that is fine. You can then get -5 times the square root of 9 times the square root of 8. All right, then we know the square root of 9 is 3, so -5 times 3 times the square root of 8 will give me -15 times the square root of 8. All right, now though, if you don't use the largest number, that means that this can still be simplified. So that means you will have to look again and say, well, are there any perfect squares that go into 8? Yes, 4 does. So we would have to do -15 times 4 times 2. We would separate them. So square root of 4 times the square root of 2. So -15 times 2, because that's the square root of 4, times the square root of 2. And either way, we still get the same answer of -30 times the square root of 2. Just if you don't use the largest number right away, then it's just going to take you a little bit longer to do. But it's not the end of the world. So if you know that one perfect square goes into it, maybe just jump straight to that right away. And that way you can start simplifying this problem to get it to a number that you are a little bit more comfortable with. If you have this really large number and you keep trying to find what number goes into it, it may be a little bit more challenging for you. So it's your call, whichever way you want to do it. They both give you the same answer. One you just had to simplify twice, while the other one you just had to simplify it once. All right, so for this problem, same thing. I'm looking to see which perfect squares go into it. And it's the exact same 3. 4 does, 9 does, and 36 does. So since I know 36 goes into it, it's the largest one, I'm going to rewrite it. So 36 is my perfect square that goes into it. How many times does it go into it? It goes into it 3 times. But remember, these are the numbers that we are focusing on, these numbers here. If none of these numbers go into it, we can't simplify it. So a lot of you guys want to say, oh, well, 2 goes into it 54 times. But 2 and 54 aren't perfect squares, so it really doesn't do us any good. So that's why I'm only focusing on my perfect squares, because then I can take the square root of it. And then I separate them, 36 times the square root of 3. Remember, I'm only doing this step because in the past I've noticed that people had trouble realizing what comes out of the square root, what stays in, and by separating it, you can focus on them individually. So you can say -8 times, well, the square root of 36, you should all know that. The square root of 36 is 6, so it's being multiplied. And then the square root of 3, well, we can't take the square root of 3 without a calculator because it's going to give us an irrational number, a decimal. So that's going to stay inside of our radical. And now we can multiply the numbers out front. -8 times 6, that will give me -48 times the square root of 3. All right, so same thing. If you didn't know which numbers went into it, you could start with your smallest one. It might have jumped out to you that 9 went into it, so you could have started with that one if you wanted to. It's your call. All right, now we have 8 times the square root of 32. Well, I know 4 goes into 32, and I know 16 goes into 32. So then which one do I use? I use my larger one. So it becomes 8 times the square root of 16, and 16 goes into 32 twice. All right, I'm going to separate them so I can focus on them individually so I know what comes out and what stays in. So 8 times the square root of 16, well, I know the square root of 16 is 4, so it becomes 8 times 4. The square root of 2 gives me an irrational number, so it stays. Well, 8 times 4 gives me 32, so it's 32 times the square root of 2. All right, these are the exact same values. These equal the same digit. It's just one is simplified while the other is not. All right, so for this one, now we're multiplying. And remember, the key thing that you need to ask yourselves when we are multiplying or dividing is, are the indices the same? Do they have the same index? So that means, are we taking the same root of them? And since these don't have any number written, they're both understood to be the square root. So you could multiply first and then try simplifying. But as we talked about in class, it's easier to simplify first and then multiply last. Because if we can simplify the number first, then it just breaks it down for us and makes it into smaller numbers so that when we multiply them together, we may not get this huge number that we don't really know what divides into it. So now we just look at them individually. Well, this one should be easy. The square root of 4 is 2. So I can rewrite this then as 2 times the square root of 2. And whenever we are multiplying a whole number with our root, we don't need to write the multiplication symbol. It just becomes 2 times the square root of 2. All right, so this one was actually really easy. There was really nothing that we needed to do except for just take the square root of 2 and then simply multiply them and write them next to each other. All right, so that is it for that one. All right, so now we have 5 times the square root of 8 times negative 3 times the square root of 6. So I'm going to try and simplify them first. Well, in the square root of 8, I know 4 goes into it, and that's the only one that does. So I can rewrite this as 4 times 2. And now I'm going to go ahead and separate them. So 5 times the square root of 4 times the square root of 2. And then that is going to give me, the square root of 4 is 2, so 5 times 2 times the square root of 2, and that will then give me 10 times the square root of 2. All right, so then for this one here, negative 3 times the square root of 6, no perfect square goes into it, so that's just going to go ahead and drop. So it's still going to be multiplied by negative 3 times the square root of 6. All right, now we check, are our indices the same? Yes, they're both the square root, they're both a 2, so now we can go ahead and multiply. And when we multiply our likes with our likes. So we multiply the whole numbers out front. So 10 times negative 3 gives me negative 30. And then we'll multiply the numbers on the inside of our radical. So it gives me 2 times 6, or 12. All right, now after we do this, we then need to look again and see, do any other perfect squares divide evenly into 12? And yes, 4 does. So that means that this can still be simplified. So it's negative 30 times the square root of 4. And how many times is 4 going to 12? 3 times. All right, then we will go ahead and we will separate this. So it becomes 4 times the square root of 3. And now we know the square root of 4 is 2. So it's negative 30 times 2 times the square root of 3. And negative 30 times 2 is negative 60. So it's negative 60 times the square root of 3. All right, you could have, if you wanted to, multiplied 8 times 6 right away and got the square root of 48. Since these numbers are a little bit smaller, it wouldn't really be that hard to do that right away and multiply it first and then figure out that 16 goes into 48. So maybe you do just multiply them right away. But if it's a very large number, it's actually easier for you to simplify first than it would be last. But it's your call. All right, so I simplified it first and then I multiplied them, and I just had to simplify it one more time. In your test, you have plenty of time to go through these questions. You should be done with 20 minutes to spare. So that means you can take your time. You don't have to rush through these. All right, but you can simplify it first. Or if you notice that the numbers are smaller, we can go ahead and multiply them. So 5 times negative 3 is negative 15. 6 times 8 is 48. I can see that 16 goes into 48 3 times, and 16 was a perfect square. I can go ahead and separate them. So 16 times 3. And then it will give me negative 15 times 4 times the square root of 3, which is negative 60 times the square root of 3. So it was the exact same value whether you multiplied first or simplified first. The only problem is maybe you have a little bit more difficulty figuring out what goes into these larger numbers than you do the smaller ones. But 48 was not a large number, so it's your call which one you want to do first. All right, so same thing, we're multiplying. First question we need to ask ourselves are the indices the same? Yes, they are, so that means we can actually multiply. All right, but before I multiply, I'm just going to go ahead and reduce. I'm going to simplify each one. Well, I know 4 goes into 12, so I'm going to rewrite this as negative 3 times 4 times 3. So then I'm going to break them apart. So negative 3 times the square root of 4 times the square root of 3. And that will give me negative 3 times 2 times the square root of 3, which then means my final simplified version of this is negative 6 times the square root of 3. All right, then I'm going to go ahead and simplify this negative square root of 8. So I know 4 goes into 8. So it becomes times negative of 4 times 2. So then I'm going to separate them. So square root of 4 times square root of 2. I know the square root of 4 is equal to 2. So it's just going to give me negative 2 times the square root of 2. All right, now we already knew our indices were the same, so we can multiply our likes with our likes. So negative 6 times negative 2 is a positive 12. And then 3 times 2 is going to give me square root of 6. All right, well, square root of 6 cannot be simplified, so that is our final answer. All right, so I have negative 6 times the square root of 56 times negative 3 times the square root of 6. All right, so same thing, I'm going to simplify first. Well, I know 4 goes into 56, so I'm going to go ahead and rewrite this as negative 6 times, and 4 goes into 56 14 times. All right, so then I will separate it, negative 6 times the square root of 4 times the square root of 14. So then this will then give me negative 6 times 2 times the square root of 14, which is going to give me the final value of negative 12 times the square root of 14. All right, they are the same exact value, just rewritten in simplified form. All right, square root of 6 doesn't simplify at all, so this is just going to drop down as negative 3 times the square root of 6. All right, now I look, or I should have looked before, but my indices are the same. So since my indices are the same, I can multiply my likes with my likes. So negative 12 times negative 3 is 36. And then here I have 14 times 6. So it's going to give me the square root of 84. All right, now after I multiply this, I need to ask myself again, does this simplify even more? Well, when you see 84, it should be really clear what at least goes into it. We know a 4 goes into 8 and it goes into 4. So I'm going to just go ahead and divide this by 4. All right, maybe a larger number does go into it, but since I know something goes into it right away, I'm just going to jump to that. Maybe that's what you do when you're taking this test. All right, but let's go ahead and see. 36 goes into it. Well, 36 times, I'm sorry. 4 goes into 84, so 4 times, it goes into 84 21 times. So then I'm going to go ahead and I will separate this. So it's 36 times the square root of 4 times the square root of 21. Well, I know the square root of 4 is 2, so 36 times 2 times the square root of 21. And 36 times 2 is going to give me 72 times the square root of 21. And 21 only has factors of 3 and 7, so no perfect square goes into it. So sometimes if you start with a smaller number that you know goes into it right away, maybe that's all that you actually have to simplify it by. So it's not necessarily that important that you keep going until you find the largest number. It just means it might take you 1 extra minute to solve this problem as one of your peers. But it's still something that can be done and can be done fairly quickly. All right, but that is your final answer for this problem. All right, now let's move on to number 12. All right, so for these problems here with the division ones, you really can do this multiple ways. You don't have to necessarily do it the exact same way that I'm about to do it here. You kind of have a little bit more freedom. You can simplify first. You can write them under the same radical, and then go ahead and reduce. You can do a lot of different things here. And I guess I'll show you both ways for this first one, and it's really up to you. All right, the first way I'm going to show you, though, is since we have 6 over 27, and if you try to think about these as one fraction, because since they have the same index, we could rewrite them if we wanted to, square root of 6 over 27. But if you do it this way, maybe you notice that when we reduce it, it's not going to give us a perfect square for both of them. So maybe you just go ahead and you leave it as is and you decide, I'm going to simplify first. Personally, for me, I would do the way I'm going to do it second for this problem, but it's your call. All right, so we can see the square root of 6 is not simplified at all, so it's just going to remain the square root of 6. The square root of 27, I'm going to erase this for now because we're going to do that second. The square root of 27 we can write off over here. What perfect square divides evenly into 27? Well, 9 does, so we can rewrite it as 9 times 3. And then it's the square root of 9 times the square root of 3, so this will then give me 3 times the square root of 3. All right, they are the exact same value, just written in different ways, simplified. All right, so now whenever we have this, we can identify our numbers versus our radicals. So we can then look at this as the square root of 6 over 3. And the square root of 6 over 3 reduces to just the square root of 2. So that means when we break these apart, remember, when we have just a radical, if we're looking at the whole number in the out front and there's nothing written, it's understood to be 1. So we can rewrite this in as 1 over 3 times the square root of 6 over the square root of 3. And then, since these indices are the same, we can rewrite it as 1 over 3 times the square root of 6 over 3, which is then going to reduce to 1 over 3 times the square root of 2. And now we just multiply them under into one fraction. So square root of 2 times 1 is going to give me the square root of 2. And then 1 times 3 is going to give me 3. So this is our final answer, the square root of 2 over 3. All right, so maybe you found that way to be a little bit harder, a little bit trickier. And I'm going to show you a second way. It's your call, all right? But I don't want to just force you to do it one way, because maybe you think differently than your peers, and someone may find this first way easier, someone may find the second way easier. Because one of the things we talked about was, if you're ever stuck and don't know what to do, simplify as much as you possibly can, all right? Because we know at least 85% of this test is simplifying radicals. All right, but let's go ahead and just erase this really fast. I'm going to pause it. All right, and now let's look at the second way we can do this. So the second way we can do this is, as I wrote before, since they're the same index, we can rewrite them under the same radical, 6 over 27. All right, and then we can reduce it. Well, I know both of these are divisible by 3, so I'm going to reduce both of them by 3. So it becomes a square root, sorry, let me write this over here. It becomes a square root of 2 over 9. All right, and now I can ask myself, well, are either of these numbers perfect squares? Well, the 2 isn't, but 9 is. So I can rewrite this then as, I can separate them and look at them individually as the square root of 2 over the square root of 9. And I can't take the square root of 2, so it's just going to remain, and the square root of 9 is 3. Final answer. All right, this way for this problem I do think is a little bit easier, but for some of the ones that we were doing for homework especially, this way was a little bit more challenging, I thought, but it's your call. All right, and one of the reasons why I think some people might prefer the first one is because I did say to you, 85% of your test is simplifying a radical. So that's something that you have to be able to do. So at any given point, if you're stuck, just start simplifying. And then hopefully something jumps out at you of what you can do. All right, that is it for this question. Let's move on to the next one. All right, so for this one, the second way that we did before is probably the easiest for this one, because as we look at these numbers, we see neither of them are perfect squares. So, but when we put them under one fraction, maybe you might notice that 3 divides evenly into both of them. But if you don't, remember, anytime you're stuck, go to simplify. Well, no perfect square divides evenly into 15, so that's going to remain. So it's going to remain the square root of 15. Well, we already did the square root of 108 before. We know that 36 divides into 108 3 times, so I can rewrite this as 36 times 3. And then I can separate them, so square root of 15 over the square root of 36 times the square root of 3. And I know that that's just going to give me the square root of 15 over top of 6 times the square root of 3. All right, and remember, once we do this, now we can separate these. I can look at this as 1 over 6 and see, do my numbers reduce? They don't. And then the square root of 15 over the square root of 3. I can then say, all right, well, these have the same index, so let me rewrite them under the same fraction. So 1 over 6 times square root of 15 over 3. Well, the square root of 15 over 3 is equal to 5, so it's going to be square root of 5, so it's going to be 1 over 6 times the square root of 5. All right, by doing that, it now got rid of our denominator, so that means when we multiply this, it's going to just give us the square root of 5 over 6, because this number is written as, it's understood to be in our numerator, because we can write it over top of 1. So it's just simply the square root of 5 over 6. All right, it is your call as to which way you do this. Maybe some people didn't notice that 3 went into both 108 and 15, so maybe they would have been stuck if they wrote it under the same radical to begin with. But it's your call. All right, this one is probably the easiest one that you guys had to do, because there's no simplifying that can be done. Square root of 15 and square root of 3, neither of them have a perfect square that goes into it. So that means we're just going to separate these and focus on our whole numbers out front, so 3 over 7, and then our square roots as their own fraction, square root of 15 over square root of 3. And then we look and see, our index the same? Are the indices the same? Yes, they are. So that means we can rewrite this as 3 over 7 times, and then we can look at the square roots as one fraction. And 15 over 3, you should all know, simplifies to just the square root of 5. And now we can multiply these back together to rewrite them under one fraction. So 3 times the square root of 5 is going to give me 3 times the square root of 5. 7 times 1 is 7. So this is your final answer. All right, so this one actually should have been the easiest problem that you guys did in this entire worksheet. All right, so now let's go ahead and do this problem. So when I look here, I see that both of these radicals can be simplified, or we can actually take the square root of them. So for 20, I know 4 goes into 20, so I'm going to rewrite this as 5 times the square root of 4 times 5. And then for the bottom one, I know that square root of 64 is 8, so it just becomes 7 times 8. All right, then I'm going to separate these. 5 times the square root of 4 times the square root of 5 over top of 7 times 8, I know is equal to 56. All right, so then I'm going to rewrite this down here. So then it becomes 5, well, the square root of 4 is 2, times the square root of 5 over top of 56. Well, 5 times 2 is 10, so 10 times the square root of 5 over 56. Now, some of you guys may stop here because you notice that your radicals can't be simplified anymore because it's already given us just that one radical square root of 5 in our numerator. However, we have to look and see, can our numbers reduce? So is there any number that goes into both 10 and 56? Yes, 2 does. So we can reduce both of these by 2. So when we do 10 divided by 2, that's going to give me 5. So it's 5 root 5 over top of, and 56 divided by 2 is 28. So 5 root 5 over top of 28. And that will be your final answer. All right, now the last problem on the worksheet. So when I look at question number 1, when I look at my numerator, I notice that 7 times the square root of 5 cannot reduce at all. So I'm just going to go ahead and rewrite it 7 times the square root of 5. And now I'm going to focus on my denominator. So when I look here, I'm going to do 8 times the square root of 125. So do any perfect squares divide evenly into 125? Yes, 25 does. So it's 8 times 25 times 5, because that's 25 times 5 gives me 125. I will separate them. Square root of 25 times the square root of 5. Well, I know the square root of 25 is 5, so 8 times 5 times the square root of 5. And that will give me 40 times the square root of 5. So 40 times the square root of 5. All right, now, anytime I'm multiplying and dividing by the same number, I know that they cancel each other. Square root of 5 divided by square root of 5 is 1. So they will cross each other out, and our final answer is simply 7 divided by 40. And since 7 over 40 can't reduce at all, that is our final answer. All right, I know this video is a little bit longer, but you could have skipped around. If you have any questions, please reach out.